So once again, very good day to everybody. We are going to discuss more about data structures. This particular class will discuss about requirements for searching as well as specifications of the search problem. Okay. Of course, I would like to dedicate this especially for the students and young researchers, the blooming researchers of tomorrow's world. Okay, and of course, you know me. You can reach me at dr.christoananth@gmail.com. So before beginning this session, let me thank God for giving me this golden opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants, students and young researchers.
Thank you.
Thank you so much. You are most welcome. Okay, so this particular class we'll discuss more about searching algorithms. We discuss about linear search to find the elements in a given list of numbers, and then we discuss about binary search also, linear search and then binary search. We discuss about the approach used for the linear search. Then we discuss about the recursive implementation of binary search, and then we discuss about the decrease and conquer. It is not divide and conquer, it is decrease and conquer. What is divide and conquer? Divide and conquer.
Like you should divide it, many parts and conquer it and make it work for yourself.
Same thing, but this one is decrease and conquer. Decrease and conquer means the bigger problem you decrease it and you solve it. Okay, right. Then you have the salient differences between divide and conquer as well as decrease and conquer, and I will give you one interesting algorithm, which is Russian peasant algorithm, which is all about multiplying two numbers using bitwise operators. Then we discuss about the search problem, and then we discuss about the requirements for searching. Okay, then finally I end up the class with the specification of the search problem. Okay, so I've already given the open-ended project work in the Google Classroom. Please complete them. Okay, and of course at regular intervals we will be having some short videos to discuss the knowledge in our topics. So this is searching algorithms. Whenever you are going for searching algorithms, you have to check for an element. Okay, you are going to check for an element and you are going to retrieve the last element. Okay, for example, if you have a purse and if you have missed it, you have come to the class of 509, you missed your purse. Okay, maybe you go to 310, maybe you go to 510. Let us take in the case. Now, maybe if in this department we have a helper, let us take in the case, helper after 6 o'clock will wipe off everything, okay, and will see, okay, there is a purse. This purse maybe tomorrow it might be with the head of the department. So the department will give to you. Okay. So what is actually going? It is checking and then it is finding out the last purse and then it is giving to you. Okay, so this is what you are going to do with the searching algorithms. Okay, so here in searching algorithms we have two types of search. One is sequential search and then interval search. Okay, in sequential search you have linear search. Okay, which means one after the another it is checking. Okay, that purse, whether it is with him, 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 like after each of the things I'm asking. Okay, for example, somebody has stolen my mobile. I ask him, him, next one. So this is actually sequential search, one after the another. This is linear search. Okay, and then we have interval search. Interval search is nothing but binary search. Okay, I divide this class into two. Okay, for example, if I feel Ramzuddin is the only one who has stolen my mobile, I divide this class into half. Okay, I leave this part. Now I focus on this part. I focus on you. I focus on you. Okay, and then I come to you. Okay, so this is how you go for binary search. Okay, right. So divide that search space into half, leave the other one and go with the other one. Okay, so this is binary search. So this is linear search. Now my question is, use linear search to find the element 20 in a given list of numbers. Where is 20?
6.
6.
Index 6.
You cannot jump directly to 6. Start from 0. 1, 2, 3, 4, 5, 6. It takes time, but it's good. It's good. Okay, this is linear search. Okay, 0 to 1, 1 to 2, 2 to 3, 4 to 5, 5 to 6. You find 20. Okay, then you have binary search. Binary search, the same thing. Find 23 in a given list of numbers. Now, in the first one, find 23. Where is 23?
Yes, 5.
5. So this one you cannot jump directly to 5, but the thing is that you should go the center part, left part, middle part, right part. Okay, divide into 2. Okay, whether this 23 is greater than or less than.
It depends on it.
Yeah. Okay, so this one 23 is greater than 16, so it should be definitely after that 4, after the 4 only. Okay, now this one 23 is less than 56, so definitely it will be lesser only, so it will be from 5 to 7. Okay, so you find 23. Okay, it is in the middle.
But if numbers place it without growing or
It should be ordered. It should be ordered. Only then we can do that.
Yes.
If it is not ordered, sometimes what happens is you can change it by a uniform position. For example, this one 2, 5, 8, 12, 16, 23, 38, 56, 72, 91. This 91 can be brought to the first, and the first will become next. Second, if that is the case, also we can search, which means that position should be changed uniformly. Like 2 position, it is changed. 1 position, it is changed.
Yeah.
You can find it. But if it is unordered means, you cannot find it. Right. So find the position forming the AP with the the access point with the prefix and suffix sum of array with common difference. So this is an example. Given an array of a size n, and then we have a positive integer which is d. We have to find the position I of the element. Okay. So we have to find array prefix sum, array I, and suffix sum. So this is the general representation. Array of I minus sum of array of 0 to I minus 1 is equal to sum of array of I plus 1 up to n minus 1 minus array of I equal to d. Okay, right. So the problem is that if you can find out the position, it is okay. If you cannot find the particular number, you have to return it as minus 1. Okay, I will give you an simple example. This is the input array of 4, 6, 20, 10, 15, 5. Now what you have to do is you have to take the middle part, you have to take the left part, you have to take the right part. Okay, so for this one, what is the middle part? Maybe you can take it as 20. Okay, this one 20. Okay, 4 plus 6, what is 4 plus 6? 10. So 10, 20, and then 10 plus 15 plus 5? 10 plus 15 plus 5? 30. So 10, 20, 30. Okay, 10, 20, 30. Okay, here this one 10, 20, 30, same thing. Okay, right. So this 10, 20, 30, you are forming an AP with the common difference. What is the difference? 10. Okay, that is the difference D, which is equal to 10. Okay, now another example we take 1, 3, 5. 1, 3, 5. This one binary search. It is finding the position. Okay, right. Okay, another array of 1, 3, 5. It is given the difference is 7. Whether it is true or not. 1, 3, 5. Difference is 7. Okay, what is the difference?
Difference 2.
Very good. The difference is 2. Okay, so since the difference is given as 7, the answer is minus 1. It is wrong. If it is wrong, means minus 1.
Okay.
So this is the linear search approach. So which means the given problem can be solved using linear search approach. And if the size of the array I repeat, if the size of the array is less than 3, then no sequence is possible, which means you return -1. Okay, so you calculate the sum of the array and store it in sum. So if the sum modulus 3 is not equal to 0, what is modulus? What is modulus? Percentage, yeah. What is this one?
So the sum of the
Remainder.
Yes.
The remainder of sum divided by 3, okay, not equal to 0, then you return 0. And you initialize a variable, say mid equal to sum divided by 3 to store in the middle element, okay. And you iterate this array from I equal to 1 to n minus 2, and then you calculate the prefix sum till that previous element I minus 1, okay. And if this temporary variable is equal to mid minus d, then the suffix sum would be mid plus d, okay. It is simple, like you take one part, okay, you divide that part, okay. So if this part doesn't lie here, you ignore this left part and you go for like a mid plus d, okay. For example, if this number is here, you ignore this part, it is mid minus d, okay. It is going like this one, okay. So if that particular element is not in left hand side as well as in right hand side, you return it as -1, okay. So if the loop terminates, which means you are going to simply return it as -1, right. So this is a linear approach where you tend to use C++ program. Hash include bits/std c++.h using namespace std function. You are going to check whether this element is forming this AP series, okay. So with a common difference d. So int check array, int array the size, and then int n, and then int d, the common difference d, okay. Now you are going to check whether this array is less than 3 or not, okay. So if it is less than 3 means you straight away you return it as -1, okay. Else means you go for the next one, you go for initializing the variables I, sum equal to 0, temporary variable is equal to 0, okay. And you calculate the total sum of the array, which is for I equal to 0, I less than n, I plus plus, okay. Now you go for this statement, sum equal to sum plus array of I.
Yeah, we know.
Sum plus equal to array of I, okay. And if this sum modulus 3 is not equal to 0, you return 0, and you calculate this mid element, okay. Int mid equal to sum divided by 3, and you increment it, iterate over the range. So for I equal to 1, I less than n minus 1, I plus plus, and then the temporary variable once again you increment it, temporary plus equal to array of I minus 1. And if this temporary is equal to the mid value, like mid minus d, then you return I plus 1. Like if it is lying on the right means plus, if it is lying on the left means minus, okay. So that's the reason, if temporary is equal to mid minus d means return I plus 1, else return 0. And then if this middle element is not found in the array, you return 0. Here you have the driver code, okay. In main function, the array you are giving it as 4, 6, 20, 10, 15, 5, okay. Here it is actually int n is equal to size of the array, size means that location, okay, right. So int d equal to 10, see out you are checking the array comma n comma d, and then return 0. What will be your output for this one? 4, 6, 20, 10, 15, 5. Same thing, 4 plus 6 is 10,
Yes.
middle is 20, the right side is 30, 10, 20, 30, okay. 1, 2, 3, so it is actually 3. So this is a step-by-step binary search algorithm. So the binary search, you already know that it is a interval search, okay. So you compare this x with the middle element, and if this x matches the middle element means we return the mid index. For example, if I am looking for maybe my search result is like nothing but finding a guy with a black shirt and black pant with a headset in the right ear, okay. I am seeing the left side, I don't find. I see in the right side, I don't find. But in the middle, I see one person with a black shirt and black pant wearing the headset. Okay. Now, when x matches the middle element, we return the mid index. It is not in left, it is not in right, but it is in the center. Okay. Else, if x is greater than the mid element, then X can only lie in the right side, leave the left. Okay. Else if here, you leave the right. So this is a recursive implementation of binary search. It's a C++ program to implement the recursive binary search. So hash include bits slash std c++.h using namespace std function. So this is actually a recursive binary search function. You have int binary search of int array, int l, and then int r, int x. L is actually left hand side, r is actually right hand side. Okay. If this r is greater than equal to 1, you have int mid equal to L plus R minus 1 divided by 2. Okay. So if this array of mid is equal to X, you return mid value. Okay. And this element is smaller than the mid means this one.
Yeah.
It is minus 1. Okay. Mid minus 1. So it is, if array of mid is greater than X means you return binary search array L comma mid minus 1. Okay. And if this element is in right subarray means it is plus 1. Left means minus 1, right means plus 1. Okay. So right means return binary search array comma mid plus 1 comma r comma x. That last statement. This one. Right side means plus, left hand side means minus. Okay. So if this element is not present in the array means it is minus 1. Okay. So we have a driver code int main of void int array of 2, 3, 4, 10, 40. Okay. And then int x is equal to 10, int n is equal to size of array. Okay, that is actually you are starting with the size of array of 0. Okay, and then the int result is equal to binary search array comma 0 comma the previous element n minus 1 comma x, and result equal to minus 1 means you print that it is not present in the array. Okay, if it is present in the array means you have to write in element is present at the which position, index which position. Okay,
In the
right.
last position means 1, minus 1.
If it is not present means minus 1. If it is present means you have to say which location it is present. Okay. Now my question is 2, 3, 4, 10, 40. Now my question is what about 10? 10.
And it's next.
10 is present or not?
Present one.
No. Here you have an array 2, 3, 4, 10, 40. Okay. My question is whether 10 is present or not. See, 2, 3, 4, 10, 40. My question is whether 10 is present or not.
Present.
Present. Where?
Index 3.
Very good. Index 3. How do you get index 3? 0, 1, 2, 3. Okay, so it is present. It is present. It is present at the
Because it begins with 0.
it doesn't begin with 1. It begins with 0. So it is present at 3. Okay. Now my question is whether 21 is present or not.
No.
So the answer is what is the output?
Element is not present in a.
Very good. Element is not present in the array.
What the following is condition. All of the programs is support this.
Yeah. Okay. Recursive implementation of the binary search. Okay. So the same thing we would go with the iterative representation also. We will have iterative binary search hash include bits slash std c++.h using namespace std. Same program but iterative search. Okay. So iterative, it's a iterative binary search function. It is going to return the location of x in the array of 1 to r. Okay. Otherwise it is going to return it as minus 1. Okay. So int binary search of int array, int l, int r, int x. L is left, right is r. Okay.
X is index or
Yeah. L is left, r is right. Okay. X is the index. Okay. So while L less than or equal to r, so int m is equal to L plus r minus 1 divided by 2. And you are going to check in the middle. Okay. Check in the middle. Okay. If this array of m is equal to x, you return middle m. If this x is greater, you ignore this left part. So it is plus 1. So if array of m is less than x, L equal to m plus 1.
X is the middle. That's it.
Now first is middle, second is right, third is left. And the third condition, if x is smaller, smaller means this side. Ignore the right half. So left means it is minus 1. So r is equal to m minus 1. Okay. If the element is not present, then return -1. And finally you go with return -1 and you go for the driver code int array 2 3 4 10 40 int x is equal to 10 int n is equal to size of the array slash size of array of 0 int result equal to binary search of array comma 0 comma n minus 1 comma x. Okay, so the result you are going to check whether it is equal to -1. If the result is equal to -1 means you print the element is not present in array, otherwise you print element is present at the location. So same thing the output, same output you get. So this is not divide and conquer, but it is a decrease and conquer based approach. So in a divide and conquer based approach, you divide the problem into a number of sub problems. Okay, you know the meaning out of it. Okay, like when you have a bigger problem, you divide into smaller problems and then you tend to work out.
Big companies just you work just like this.
Yeah. So for each of the thing you will have a solution, gather the solution and then combine it. Okay. So and then you conquer the sub problems by solving them recursively. Maybe if it is not small enough, once again you subdivide it. Okay. And then you combine the solutions to find out the solution for the original or the main problem. Okay. So similarly you have decrease and conquer approach. Decrease and conquer means you reduce that problem, the bigger problem you reduce it. Okay. Just in the same case, for example, you have to register your mobile in the post office. Okay, it is a bigger problem for me. For you it is a smaller problem because you already know some person there. Okay, so you will finish it in 2 minutes or 5 minutes, but for me it will take 15 minutes.
Wow.
This is reduce and conquer, decrease and conquer. Okay, right. So this is divide and conquer versus decrease and conquer. You conquer the problem by, with the case of decrease and conquer, you conquer the problem by solving smaller instance and then you extend the solution for that original problem. So this decrease and conquer, you can also call it as a incremental based approach or maybe an inductive based approach where you tend to decrease them in order to get a incremental solution out of it. Okay, so I would like to compare between divide and conquer and decrease and conquer. In divide and conquer, you have merge sort as well as quick sort algorithms, and then in the case of decrease and conquer, we have binary search or maybe interval search. So these are the implementations of decrease and conquer. We have top down or bottom up. What is top down?
I'm searching from the roots.
Top down, from the top it goes to the down. Okay, if the rector says the students should participate in the competition, rector informs the vice rector. Vice rector tells the head of the tells the dean. Dean tells the head of the department. Head of the department tells the tutor. Tutor tells you.
We tell.
No, the information it should come from like this. Rector doesn't meet the students personally.
In your university too, rector doesn't meet in a personal.
No. Only during the functions. Only during the cultural festivals we see. Other than that we goes. Okay. What is bottom up approach?
Students.
If you have a problem, you tell the tutor. Tutor tells the head of the department. Head of the department tells the dean. Dean tells the vice rector. Vice rector tells the rector. And there are variations of decrease and conquer also. You can decrease it by a constant. You can decrease it by a constant factor. Okay. And also you can have a variable size decrease. You can decrease it by 2. You can decrease it by 3 uniformly. Okay. Or you can have variable size decrease. Okay. Then with the case of the decrease by constant, as I told you, you can decrease by a constant uniformly. Okay. So you have insertion sort. We have like graph search algorithms as well. We have DFS and then we have BFS. Depth first search and then breadth first search. Okay. Then we have like topological sorting as well, where we would be working with permutations and subsets even. Then we same thing, we will decrease it by a constant factor also. Okay. Then we have binary search as well as fake coin problems. And there's an interesting problem, an interesting algorithm. We have Russian peasant multiplication. I will discuss about this one. Okay, and then we have variable size decrease also. So maybe it can have a variable size maybe like 2 uniformly, or maybe 3 uniformly, or maybe after maybe step 3 or step 4 we can have a decrease by 5 also. Okay, that also you can do. And similarly we can have like computing median and selection problem, interpolation search, as well as Euclidean based approach. Right. So this is a Russian peasant algorithm. The understanding the logic is very easy. Okay. So let us take in the case you have two numbers. Now the question is you have to multiply the two numbers. Okay. So the idea is that this is the basic idea. First number you double, second number you half it. Okay. You repeat it till the second number doesn't become 1. Okay. This is the process. Okay. In the process, whenever the second number is an odd number, okay, you add this first number with that result. Initially that result is actually 0. You add this result with the first number. Okay, when the second number becomes an odd number. Okay, now let us take an algorithm, you will understand things better. Okay, so take two numbers A and B, initialize the result to 0. Initially result is equal to 0. Okay, now while B is greater than 0, okay, then you again you check. If B is an odd value, then you add A, the first number, to the result. Result is actually 0. Okay, right? And then you double A and then half B. Okay, and then you return the result. I'll give you a program. So this is a C++ program to multiply two numbers using Russian peasant method. Okay, so hash include IO stream using namespace std function, and then a method to multiply two numbers using the Russian peasant method. So unsigned integer int, Russian peasant of unsigned int of A, unsigned int of B. So in unsigned integer, which means it's not a signed integer like the sign means plus minus. It is an unsigned integer. It doesn't have plus or minus. It's like modulus value, modulus of phi, original number. Okay. So int rest is equal to 0. You initialize the result equal to 0. So while B is greater than 0, okay, then you check if B ampersand 1, okay, you go for this one. That is B ampersand 1 means if it is an odd number. So your result is equal to result plus A. Okay. Then what you do? You double the first number and half the second number. Okay. And then you return the result. Then you have a driver code. Okay. So here int main cout you print the Russian peasant of 18,1 and then cout Russian peasant of 20,12. So what you are going to do? You are going to multiply 18 and 1 and then 20 and 12. That is the result. Okay. So what is 18 multiplied by 1? It is 80. 20 multiplied by 12, it is 240. Now comes search problem. So in the search problem, it's a mathematical representation where you represent by a binary relation. So here the binary relation you represent it as R. Okay, R is a binary relation such that R belongs to that subset. You remember subset? It falls inside. It falls inside. Okay, R belongs to the Turing machine T. So now T is going to calculate the relation if X is such that there is some Y component in R of X comma Y. Okay, now T accepts X with some output Z. So we have the relation R of X comma Z. Okay, and similarly there is also X in which there is first part is there is some Y component. Second is there is no Y component in such that R of X comma Y such that then T rejects X. The first case it accepts, second case it rejects. Okay. So if this item, the thing is not present, it shows item not present. Okay. So this thing we can use it in the Turing machine. The alternate name for this search problem is the decision problem because it is deciding whether that particular element is present or not. So these are the parameters of the search problem. we have a set of states, we have a start state, and then we have to have a goal state or goal test. Okay, I will explain this with a simple example. For example, my goal is identify a person who knows Java, also knows English. Let us take in the case. Let us take in the case. In this class, I don't find anybody. Let us take in the case. What I have to do? I have to do in the interview. In the interview, I find one person very good in Java. He doesn't know English. I reject him. Another person, he knows English. He doesn't know Java. I reject him. Okay. Maybe after some days, I find one person who is good both in Java as well as English. I find out him. I get him. Okay. So this is the unexplored node. These are the explored nodes. I know about you. You are the explored nodes. The unexplored nodes, I get to know about them and I test them and I find out the goal node. Until I find out the goal node, I keep on doing this one. I keep on doing this one. Okay. So this is the search problem where you tend to explore these features in the generic search algorithm. So this is the basic implementation of the search method. Input, that's a graph, a set of start nodes, and then we tend to follow a Boolean procedure goal in such that it is going to test if n is actually the goal node. Okay. Then you have the frontier or the base. We have the start node yes. While the frontier is not empty, you select and remove the path for n of 0, n of 1, n of 2 up to n of k from the frontier. If this goal of n of k, then you return n of 0 up to n of k for every neighbor from n of k. Okay. So and then you go with the end y. So there are some requirements of searching also. So whenever you are dealing with the data structures, generally you will tend to define data structures that is that the computers can also identify, and also the computers should perform the same way, should think the same way as that of the human beings. Okay. So that's the way we go for a represented, a structured representation of the data structures. Okay. So that's the reason we go for searching in a defined way. Okay. So our basic objective is that our way of searching, the way of representation should be very simple enough, should be understandable for everybody. Also, the algorithm or the method that we are tend to using, it should be very powerful enough. Like whatever may be the test case, it should provide the required result. Okay. So this is an example. This is an example. Just carefully look into the example. We have 1, 4, 17, 3, 90, 79, 4, 6 and 81. Okay. This one I'm talking about. That one I'm talking about. Okay. Whenever you are giving this, whenever a problem is given, you write it with a square brace. That's an array. So a square brace of 1, 4, 17, 3, 90, 79, 4, 6 and 81. Now my no, both of them is the same. Whenever you are given with a square bracket or maybe a curly bracket, you write it with a square brace. That is the structured representation. Structured representation. And now my question is, where is 17?
17 is 2.
Very good. 17 is 2. Okay, 0, 1, 2. Where is 91?
91 is done, that doesn't exist.
What is the answer?
Minus 1.
Very good. Minus 1. If it is not present, it is minus 1. If it is present, means you have to give the index or the location.
Minus 1 is because of index is sub 0.
Yeah.
And minus 7
doesn't exist.
Yes. Yeah.
Yes.
Why?
We always use -1 to find the
because
if the element is not present, it is minus 1.
Yes, because minus 1 doesn't exist in indexes.
Yeah.
Because in index is sub 0 and minus 1 is
Yeah. Right. So given an array A and integer x, you have to find the integer I such that 1 where there is no j such that a of j is x, then I is minus 1 comma 2. Otherwise, I is any j for which a of j is x. Okay. Right. So maybe if there is a case with 17, 13, 17, so we will have like x is equal to 17.
One more time, just do this.
So once again, I am repeating, open-ended project work. You have to do it. Okay. With data structures.